Okay, thank you for joining me this week. So, welcome to the summer sessions of our programming contest club. And I guess I'll first go through a little bit of how we do things in the summer, and then maybe I'll get to the problems after that. So basically, we can run everything off open.caddis.com. I will be posting links to a weekly contest that I set up every week. Probably every Friday, I will be posting a set. Now, these problems, if you go to open.caddis.com, um, so let's go back to the original here, open.caddis.com. On the left-hand side, you will see problems, contests, and we will be going through the contests. And you'll see a list of ongoing contests that people have set up. And you will find in this list one of the ones that I set up when I'm recording this contest actually hasn't gone live yet. So it will be right now it's under upcoming because I'm recording it before May 2nd, but when you watch this video, it should be in the list of ongoing contests. And I've already logged in, but if you haven't logged in yet, you can log in. If you don't have an account, you create an account, or you can log in through your Google account or LinkedIn, and there are a number of different ways you can connect to other credentials. So it's up to you how you want to log in. Um, anyway, and if uh, the contest close, because I can only set up these contests to run at most for 7 days, which is how long I've set it up for. But let's say you want to do a problem that's in a contest, but it's not the contest is not ongoing anymore. You won't be able to submit to the contest, but you can go through the problems here like this, and then find the actual problem. Now, it might be a little bit hard because there are a lot of problems here. If alphabetically, there are 48 pages of these problems. But what you can do is you can just go to the URL, open.caddis.com/problems, and then just slash the name of the problems. So for example, one of the problems that we looked at is called and then you can go to here and you can still submit outside of the contest and still do them if you wish. Also, let's go back to this contest. Once you're in the contest, again, you won't see exactly what I see because you can't, this is my interface. You can join the contest and then the problems will be listed. There'll be standings. Basically, it keeps track of who is in the contest, how many they solved. Don't worry about the time, right? So because in a normal contest, you're solving problems as quickly as possible. So how long it takes you to solve a problem will be a factor in your ranking. But because we're opening it up for 1 week, some people might not even look at it until like 2 days have passed. So obviously, your time will be slower than somebody that start right away. So don't worry about the time. This is just for practice. It's not a real contest. Uh, just try to solve the problem. So I plan to open up a contest every Friday. That's the plan. And then I want people to look at the problems and try them on their own. And hopefully you can actually do them yourself. But then the following week, probably about Tuesday or Wednesday, I will be posting a video like this one that explains how things are done. Okay. And then you can go if you haven't figured out by then, or tried and failed, you can then follow what I talk about and try to complete it. My advice is that no matter whether you've done it or not, or even if you've done it, but you maybe after watching my videos, you think that my method is better, do it again. Or then if you haven't finished a problem before, even if you are just following what I tell you, do it yourself. Um, again, uh, any problems that you haven't solved, do them because you can never really understand something unless you try to do it yourself. Okay, so even after re-watching my videos, even after reading my code, turn that off, try to do it yourself, even if you just try to remember, try to reproduce what I showed you, and then that would be a way for you to learn that material and improve. Also, if you ever want to go and see what my solutions are, you can go to my GitHub. So if you go to GitHub, my ID, it's Howard Cheng Uleth, and my repository is just contest. And under the contest repository, there's a subdirectory called Kattis. And then, of course, all the problems, it's the name, it's labeled by the name of the problem. So, for example, if you want to know how I did this problem you can click on that and you can see. Most of my code are uncommented, okay? And you have to figure out what I did, okay? So, but of course, you should not be looking at that right away. You should try it yourself and then see what happens. See if you can figure it out. But even after you figure it out, you might still want to look at my solution because I might have done it in a different way. And you might want to look into it and then see if there's anything that you might want to learn from that. Okay. All right. So that's the way we run things. And as usual, there's a Discord channel about compat programming. There's a chat. So feel free to ask any questions, and either me or other people that have done the problems can chime in. Don't be afraid to ask anything. Okay. All right. So let's get started on the problems this week. For the first couple of weeks, especially people, I guess I assume that whoever is joining here have at least some basic knowledge of programming. Most of you probably have at least 2620 now because you've gone through the first year. So I won't be going through, how to write a for loop or things like that. But I won't assume that you have more than 2620. And we will work our way up through the summer to more and more advanced things that will probably touch on things that, or maybe even go beyond things that you'll learn in 3620. All right, so let's look at these problems. The first couple of weeks will be relatively, I would say, it's more straightforward and maybe don't need this much advanced knowledge. But I always like to add a couple of problems that requires a little bit more thinking, just in case, well, I shouldn't say just in case there are people here that have done this before and have been maybe even the third or fourth year. And so you, of course, know more things, and you also probably want to have a little bit more of a challenge. All right, so let's start. I'm going to assume that by the time you watch this video, you have already read the problems. Okay, so I'm not going to read the problems with you. I'm just going to highlight some key points. And then I'm actually going to go through a submission with you because some people have never done this before. So I would like to show you how it's done. All right. So problem. So there's this guy that shouts too much, and the doctor instructions say and then sometimes this guy cannot say that the as long as the doctor wants. So he wants to compare how long he manages to hold the compared with the doctor's requirements. So each day, this guy calls up a different doctor and asks him how long this has to be, and find out if he should waste his time by going to the given doctor. Okay, so there's usually a story of some kind that tells you what the problem is. In this case, it just tells you that the doctor wants a certain length of you can do a certain length of so should you go to this doctor? Okay, so then the next section usually always is a description of what the input looks like. So you have to read this very carefully because it tells you a lot of things. So first, it comes in 2 lines. The input consists of 2 lines. The first line is the that this guy is able to say. And the second line is the that the doctor wants to hear. Then it tells you that this input will only have a bunch of A's followed by a single H. And it's at most, there could be no A's at all. and could be at most 999 A's. Is that important? Maybe, maybe not. But all of these, you should be used to the idea of what looking at any restrictions on the input. And when they don't say any restrictions, then you have to assume that there is no restriction. Okay, so usually they're very careful. So they will not try to trick you and give you something that's outside of what they state. So they will not give you 1000 A's followed by an H. That's not allowed. Okay, and then it says the output, you're supposed to output go if John Mears can go to that doctor and no otherwise. And that's it. No more, no less. Do not print any more prompt, uh, and so on. If it tells you to output a single word, that's the only thing you should output. No blank space, no extra blank lines, etc., etc. Okay. And now the judges are sometimes a little bit more lenient, depends on how it's set up for a particular problem. So uh, you might discover that sometimes for certain problems we can have extra spaces and still be accepted, but uh, usually it's not a good idea. Usually you try their best to follow what they say. Okay, so now let's look at how we do this. All right. Um, so I cannot show you how to do this interface right now because the contest is not live. So I'm going to go outside of contest to try to do it for you outside like this. Okay, so the first thing is that um, on the right-hand side, there's this thing called metadata. You might want to look into that. You will not see this difficulty tag in a real contest. This is only shown outside of a contest. And the most important thing that you want to see is the CPU time limit. Now, basically means that your program will be allowed to run for 1 second to solve any particular input case. Okay, for this problem, really there is no issue unless you do something extremely strange. That you know, computers are very fast. 1 second can actually do a lot of things. Okay, I would say 1 second you can easily do a for loop that has tens of millions of iterations. Okay, because if you think about, how fast our computers, we measure things by gigahertz. Gigahertz means a billion cycles a second. And of course, you may know that some instructions may take more than a billion. It may not be 1 cycle per second and so on, but still, we're talking about possibly billions of instructions per second. And so in 1 second, you can do millions of things for tens of millions of things with no issue. So for the problems that I chose this week, and perhaps the first couple of weeks, runtime usually should not be a problem. Okay. So now the next thing is, if you want, these are the sample inputs, yes? You can download them somewhere instead of typing them in, because if you're trying to type it in or even copy and paste, you might make a mistake. And then, you wonder why your program is not working when you try them out, and then it turns out that you're actually typing in wrong inputs. So of course it's not working. So it's probably better to just download the sample files. Okay, so let's save it in my download directory. So we'll go to a certain place. Let's go to tab. Let me get rid of some old things here. And then I will, some other things. Where is it? Where did I download it from? Oh, it's probably called R. And then I unzip it, and it will have all of these. Uh, Let me get rid of the zip. So one answer dot two, that would be the sample input one and sample input two for dot in, and dot ans is the output, right? So if I just look at it, that's exactly what sample input one is. And if I look at what the answer is, that's it. So I can look at these files and then I can use them. Okay, I'll now show you how to use it. Now, to program this, you could use this editor in the website, but I would actually argue against it because you can't really, it's a little bit hard to use. There's not a lot of, your standard environment, completion, bracket matching, and maybe all those fancy things. Maybe you can argue that it's good that you don't have that, but anyway. And then also, you can't compile and run it, which, for some people, that's actually a good thing. Okay, so anyway, we will open up whatever favorite code editor you want to use. I use Emacs, but whatever you want to use, doesn't matter. So here we are. And now let's start typing code. Now, so what is it that I want to do? I have, in this case, two strings of R's, and I want to make sure that my string is at least as long as the one that the doctor wants. The actual content doesn't really matter. The only thing that matters is the length of the string. And basically what I want is that my string is at least as long as the doctor's string. And that's it. Now, we have to be very careful when I say this. I said at least as long. So if both strings are the same, then I can actually go. Right? When you think about, even if something as simple as this, always think about not just the general case, but also what we call the boundary case, right? So if the first one is less than, you say no. If it's shorter, you say no. If the first one is longer, you say go, but then you also have to ask, well, where's the really critical point? It's like when it switches from less than to bigger than, that's the boundary. That's the part where they are both equal, and then you have to think a little bit. In this case, maybe you don't have to think very much, whether you want to say no or go. And that's very important when you do program. It's these boundary conditions. So in other cases, in other problems, it might be much harder. But anyway, that's what you have to think about. Okay, so now basically all I want to do is basically read the two strings and compare the length. So we start a C++ program. I mean, if you want to use other languages, you can, but I'm going to assume that everybody's going to use C++ because that's what we teach. So what's the first thing that we do? We have to include some stuff. What do we have to include? We have to include IOStream for the input output, and we have to include string for the working with strings. But competitive programmers don't want to, try to do things as quickly as possible. And if you're using G++, which is what this website is using, there is a special header called bit/stdc++.h, which includes basically everything that is under the standard C++ library. Now, this is non-standard. This is only available in G++, and it's highly, how should I say, it's a bad practice in doing just about anything other than compared programming, because you generally do not want to include everything that you can possibly include. You only want to include things that you really need. However, instead of trying to remember what you need and you're trying to typing one of those things at a time, in compared programming, when you try to squeeze every second of your coding time out of the equation, this is an okay thing to do. So this is what we'll be doing, but just keep in mind that this is not what you should do in, I don't know what you wanted to call it, real life. You're writing real code. Okay. And then we'll do this again, so we don't have to type std : everywhere. And then we would have a main. So what do I have to do? I have two strings. Now, in Uh, as I say, in most courses, you're supposed to give meaningful programming variable names and function names and so on. And I would encourage you to do so if a problem is not so simple. Okay. In this case, because the problem is so simple, I'm not going to care so much. So I'm just going to S1 and S2. You might want to actually call them John and Doctor or John string and Doctor string or whatever. Okay. But anyway, I'm just going to do it with S1 and S2. I'm going to read them. Now, remember that when you read like this only works if the string doesn't have any spaces. And then, of course, in this string, in this case, it's just A and H, so it's fine. And then I just go if S1.length. Now I have to be very careful. So I want to say, let's check, if it's if the length of the string of the first one, John string, it's less than the doctor string, then I want to say no. Otherwise, I say go. That's all you have to do. Now, you always should ask, should this be less than or should be less than equal to? Right. So this is what we call bound. We were talking about in terms of boundary conditions. And so we have to remember that when it's equals, we want to go. So if we want to write it in this way, then we do not want less than or equal to, because that would be wrong. We want less than. Okay, so that's what happens. And you probably want to compile it and test it, even if you're sure. So to compile it, the way that you compile it, you use G++. I'm assuming that you're in some kind of Linux system. If you're on a Windows system, then you have to figure out the equivalents, but you've probably seen this in your 2620 or other kind of courses. Okay, so -O, the name of the program that you want to produce, the name of the file, and we usually currently it's C++17. Most of the time you probably wouldn't notice the difference as long as you're doing C++11 or above, but this is the one that Kattis is doing. And then I always do -WO. This means turn on all warnings. Things that are not necessarily wrong, they're legal C++, but you maybe you did something wrong. They're they're sort of common mistakes that technically it's not a wrong thing to do, but maybe you're wrong. So we'll warn you. So for example, if you write if A equals to B like this, the warning will, so let's I know this is not what the problem requires. This is a very common mistake in first year programming because they forget that you're supposed to use 2 equals sign. And now if I compile this, it will give me a warning here saying, if you really, really want to use the assignment as the truth value inside if statement, you probably want to, it's more better style to do this to say that you really, really know what you're doing. But probably you did, this is not what you wanted, probably this is what you wanted. And when you compile it like this, it will not tell you anything. Okay, so when you compile with warning, it can give you some idea of things that may be wrong. Now, you are also, of course, free to ignore the warnings if you really know what you're doing. And then we will see maybe some other times where it's some warnings can be enough. Okay, so anyway, now that I have run it, compiled this, now I want to run it. And you might say, okay, let's run it like this, right? So you run the program and then you type AH, and it says no. So remember when I'm typing, this is my input and this is my output, and it looks right. But maybe it's wrong, and then you try to fix something, and then you run it again, and you keep on having to type the same thing over and over again. So the best way to do it is actually run the program, use the less than sign, make sure there's a space between the program name and file name, and then uh, the name of the file, like this. What this does, it will take the content of the file and send it into your program as if you are typing these letters on screen by your keyboard. And if you get used to this idea, then you know for sure that every time you run things, it will be exactly the same input, right? You're not going to accidentally copy something wrong. Now, if you're in a Windows environment, then you have to be a little bit more careful because I'm not exactly sure how you trigger. This is what is called input redirection. And but this is how you do it on Linux. If you're on Windows environment, you might want to consider installing things like the Windows subsystem for Linux, WSL, and which basically gives you a Linux-like environment that you can work with. Okay, now another thing is for this particular output, it's perhaps very easy to say, is it right? Is it wrong? Know when go. But maybe there's, for some other problem, the output can be a more complicated wall of text, and it's a little bit harder to figure out. So another trick is, at least on Linux, this will work. I can use the vertical bar, which is called a pipe character in Linux, and that take the output of the thing before the pipe and send it as the input to the next program that I'm going to run. What is the next program that I'm going to run? It's called diff. Diff takes two files and compare them one character at a time. The first file in Linux, the file name minus sign, it's a special file. It means don't read from a file, read from the input. And in this case, because of the way that I connected with the pipe, the input actually the output of my program. And then the second file I want to compare, it's the answer. And when there's no output like this, that means that everything's fine. There's no difference. So let's maybe introduce something. Maybe I put an extra space. So I need to recompile the program. And when I run it, it will say that there's a difference between, and it's in line one of the first file and line one of the second file. In this case, there's only one line, so it's not that important. But if you have multi-line output, then this tells you where to look. And C means there's a change, and you say, well, that looks the same. It says this one is what it looks like in the first file, and this one is what it looks like in the second file. And you say, well, it looks exactly the same because space you can't see. Okay. When you see that kind of thing, then you would expect that you should be looking for extra spaces. Or maybe, if I add an extra character that's visible, then it'll be like this. Or if I decide to add an extra black line, then it'll say 2D1. What does that mean? It means that the first file in line 2 needs to be deleted to match sort of what's to basically match the second file. Okay. Anyway, this code is not important unless you really want to know what's happening. But the fact that the number 2 appears means that there's something wrong with line 2 of your output. The fact that anything appears means that there's something wrong. Okay, so let's get back to here. And we just run it again, make sure that we haven't screwed up. Okay, and now if we're happy, you might want to check it on, more input, right? So for example, we said, what about if the two words have exactly the same length? It says go. Is that what we want? Yes. Okay, you can probably actually make this into file instead of typing it like this. Okay, so if you are happy with this, you would say upload files. You go and where is it? Home, tab, You always submit the source file. Do not submit the executable. If you use .cc or .cpp, it will automatically default it to C++, but you can change it to other ones if you're programming any other languages. So anyway, and then move this. There's a submit button, and you submit, and it's gonna start compiling, and that's running. Each of these circles is a test case, and it will tell you it passed the test case. Now, in a real contest, a regional contest, it will not give you this check marks. It will just give you one single check mark, red or green. Only the judges get to see how many test cases you actually passed. But in this case, because I set up as a practice, it will allow you to see all of them. And it's accepted, so you're done. Now, what can go wrong? Right, so we can try doing things that are wrong. So actually, I can edit and resubmit right here because and I can say, let's you know, introduce this error by adding this equal sign. So when they're both the same, I do the wrong thing. So I submit it again. And this time it passed the first two tests, and I guess that right away they test you something. The third case is the case that it's equal to bound. Okay, what else can I do to try to, what other things can I try? Maybe I can do something like this. No, actually, even better, try to write. Okay, what is this supposed to do? It's supposed to write the character A in the whatever number of positions. 100 million. No, let's just make it 1 million position. Of course, the string is not that long. So if I do this, it's going out of bounds. So I hope, you never be sure, but I hope that the program will crash. So let's try to run it, submit it, and see what happens. And it'll tell you runtime error. Runtime error means that your program has crashed. What else can we do? We can try to maybe write an infinite loop or something. Okay, so this is a for loop that basically doesn't stop until the integer goes so big that it becomes negative. And I just, that's 0 equals the first character equals to, I don't know, I log 256. Okay, the 250, actually just do 128. 128 possible values for my first character and just repeatedly assign them to the same thing. So this, so I have to do something here because otherwise the compiler might just say I'm not doing anything useful. So it just optimized the whole loop away. So I have to do some kind of computation here to outsmart the compiler. So this is supposed to run too long. And if I submit it, let's see what happens. Oh, okay, so you see compile error because it should not be S, it should be S1 or S2. So with compile error, it actually tells you that what the compile error is. So let's try again. And it runs, and it says time limit exceeded. So it goes over the bigger than 1 second. But when you see time limit exceeded, you have no idea if the program will eventually give you the right answer or not. Basically, all it does is if it's bigger than 1 second, it kills your program. So your program may be right, your program may be wrong if given enough time to run. Okay, so that's kind of shows you sort of the mechanics of how things are. done. And I'm going to stop my recording now, and because I don't want my video to be too long. And then I will start a next um, video talking about the other problems.